Designing stairs requires handling multiple, often contradictory, design, client, and regulatory requirements. Compliance can be a challenge. Tackle these challenges with the enhanced features in Archicad's intuitive, flexible stair tool. Calculate the total length of the stair's walking line in one of two ways, either along the arc or the chord. The along chord calculation method is a new option. When measuring along the chord, the tread depth is measured along a straight line. The along arc method remains unchanged. Choose the calculation method that complies with your local standards. Enjoy even more flexibility in the design of the winder thanks to the new asymmetric going option. It's available with all 4 winder turning types. Let's create 3 stairs to see the difference. For the first stair, we use the riser option. For the second, the symmetric going option. The third option is asymmetric going. Here, Archicad will place the tread with different dimensions on both sides of the turning point without keeping the symmetry. Choose between equally landing start and landing end options in the new Distribute Extra Landing Length setting to control automatic landing geometry. Let's take a look at how they differ. Thanks to the enhanced Archicad Stair tool, you'll enjoy greater design flexibility while still complying with local standards. Model-based BIM collaboration workflows between architects and other stakeholders rely on quick and easy model exchange and accurate model checking tools. Seamless collaboration with Revit is crucial for many architects. The RFA RVT Geometry Exchange add-on is now built into Archicad. Let's see how this versatile tool works. Export RVT models from Archicad. Hotlink RVT models into Archicad with precise geometry and properties. Import MEP equipment into your Archicad project in addition to doors, windows, and objects using the Import RFA as GDL object command. Let's see an example of placing an outdoor roof-mounted air conditioning unit. Activate the Import RFA as GDL object command. Locate the file and open it. Confirm the recommended MEP equipment as the desired library part type. Optimize the geometry on the slider and click Import. After the object is imported, locate it in the embedded library. Then set its parameters. It has similar options to native Archicad MEP elements, for example, various MEP systems for each connection. After placing the object, integrate it into your MEP model by connecting it to the existing piping system. The enhanced Archicad Solibri connection add-on saves time with an instant quality check of your project. Download the add-on from graphisoft.com. Install it, then open its palette from the window menu. Click on Start Solibri. When Solibri is running, click Export to Solibri. The model will automatically appear in Solibri. After making some changes in the model in Archicad, click Update in Solibri, and it will update only the changed elements. This is much faster and easier than exporting the entire model as IFC again. Let's see how the new functionalities work. Export views of the structural analytical model. The analytical members of these views will be transferred to Solibri with their physical counterparts. Transfer the selection basket's contents and even the viewpoint from Solibri to easily select the same elements in Archicad and start working on them by using the Get Selection Basket plus Viewpoint command in Archicad. Enjoy the benefits of smooth, seamless collaboration with all project stakeholders thanks to Archicad's enhanced collaboration tools. To learn more, Archicad enables model-based open workflows between the project stakeholders using different applications. A new built-in tool, the native survey point, is an integral part of the Archicad project. Show or hide the survey point and access its settings with a dedicated tool on the standard toolbar or in the Project Preferences menu. The survey point can only be seen on the display. It won't appear in printed format, and you can move it easily. As we zoom, the size of the symbol stays the same. Turn on the coordinates to show them in relation to the project origin. Set the true project north direction in a graphical way. As the north angle changes, the survey point changes its position because its coordinates are fixed. Use the Zoom to Survey Point command to easily find it in the project. Quickly access the location settings from the toolbar. This is where you can add georeferencing parameters as IFC information too. Let's see how to position the project to real-world coordinates. The project origin is set to the agreed base point of the project. Use the tracker to input the easting and northing values to relocate the survey point at the given data point. The coordinates will be automatically updated in the location settings. Use the new survey coordinate object graphic symbol to display the coordinates of any point on your plan in relation to the survey point or 3 other reference point options. The point coordinates are automatically updated if we modify the survey point. Schedule these objects to create a list of important coordination points in your project. The survey point is integrated into Archicad's coordination workflows with various file formats using the project's native survey point data. Align the incoming DXF or DWG drawings with the survey point by activating the related checkbox in the Attach XREF or the Merge dialogues during the import. For hot link modules, Archicad or IFC, choose the survey point instead of the project origin to align the imported module with the host file. When exporting an IFC or DWG file, use the dedicated options in the translators to match the exported file's origin with either the project origin or the survey point. Eliminate coordination inconsistencies and simplify your workflows with the native Archicad survey point. To learn more. Thanks to Archicad's continuously expanding 3D object libraries, and especially the highly customizable modular kitchen cabinetry, it's easier than ever to design kitchens that offer clients multiple design options to choose from. Kitchen cabinet elements are grouped by their spatial arrangements into 3 main categories: base, standing, and wall. Cabinets are further grouped into different geometries. For example, block, chamfered, closing, L, C, or S-shaped elements, making it easy to choose the one that best fits your project. Each element is highly parametric, containing a wide range of customizable components, such as the counters, panels, and knobs. It's easy to mix and match these to achieve the perfect result. Design any kitchen quickly and effortlessly using the parametric modular kitchen cabinets. Simply place the elements, stretch them to the desired size, then customize their components. Experiment with different styles, make changes quickly and easily, and deliver multiple design options for your clients to choose from. Support for load handling and load-related data means architects and structural engineers can work together seamlessly without losing load-related information. Let's see a real project workflow. After generating the structural analytical model in Archicad, the engineer activates the relevant options in the SAF export translator to retain the load-related data. After that, they export the analytical model in SAF. After importing the SAF in the structural analysis software, for example, SIA Engineer, the engineer adds loads, defines their values, and the related data. After that, the analytical model is exported and sent back to Archicad. Once in Archicad again, the engineer uses Model Compare to import only the changes, in this case, the loads. They then select the changes to be imported and add them to a new issue. After accepting all the changes, let's return to the 3D view, where all types of loads are shown as load elements. By selecting any of them, the load-related information is accessible in the Loads Settings dialog. The engineer can quickly edit these values and can even place new loads in Archicad if necessary, using the dedicated load tools, surface, line, or point loads. Moving forward with the project, the architect changes the geometry of a few beams. The analytical model is fully aligned with the physical model, and the loads follow the changes too. Then the engineer saves the analytical model in SAF again. After importing this version of the analytical model in SIA, all load-related information is updated and retained. There's no loss of information. Thanks to the support of loads, load-related data, and all released SAF versions up to version 2.0.0, engineers no longer need to recreate loads during round-trip collaboration, saving them time and effort, reducing the risk of errors, and making the entire collaboration faster and more efficient for both parties. Multi-segmented beams and columns generate a single 1D member in the analytical model based on the replacement profile. The engineer can control the alignment of this profile to better match the physical model. Let's look at an example of a multi-segmented beam. In its settings dialog, we can see all its parameters, properties, and its reference axis, as well as the position of the 1D member and the replacement profile. The engineer can override the alignment of this profile here, which also changes the position of the analytical member. Engineers can now control even more complex geometries of real project scenarios thanks to the enhanced offset adjuster. In this example, the analytical members of a column and two beams do not intersect, so the model is disconnected. We need to offset the analytical members so that they intersect. The engineer will create a new combination of two rules to achieve this. The first rule is a column-to-beam offset. There are 4 new options here to define exactly how this offset should happen. We need one more rule, beam to column, to define the stretch of the beams. The new rules are automatically applied, the model is instantly updated, and the model is now continuous at the element's intersection. Engineers can easily manage situations where 2D analytical members partially overlap with another adjustment rule enhancement. In this example, the analytical members of the two slabs overlap at different heights and are disconnected. The engineer first creates a new offset rule to align the slabs in height. Then adds a cutback rule to eliminate the overlapping parts. The result is a better quality analytical model with less errors to fix in the analysis software. Engineers can save time by placing multiple supports to all selected load-bearing elements at once. Let's see how. Go to Design, Structural Analytical Elements, Create Structural Supports. After choosing the right options, click on Create, and all supports will be placed at once on all selected elements. Thanks to Archicad, collaboration with engineers is smoother and faster, saving time and resources. Use Archicad's multiple features and commands to easily find and select elements. Show selection or marquee in 3D. Show all in 3D. Find and select. Filter and cut elements in 3D. 3D cutaway. Keep track of selected elements when switching between 2D and 3D views without having to reselect them thanks to new and improved commands. In this example, we'll check the selected opening in 3D. Right-click on it and activate the Select in 3D command. The 3D window keeps the element selected. Control element visibility and speed up your workflow when working with overlapping elements in 3D by hiding selected elements. This will make other items more visible without hiding their layers or modifying layer combinations. Simply right-click on the element you want to hide and choose the Hide Selection command. Save this custom view for later if you want. Now let's select a pipe and use the Select on Floor Plan command. The floor plan window instantly shows a close-up of the selected element in its environment. Use the Show All command to unhide the hidden elements and return to the original 3D view. Use this functionality in sections, elevations, and interior elevations as well. Track selected elements in any view, 3D or floor plan. Save time and navigate more easily between views and use multiple, flexible options to control element visibility. Component properties. To learn more about... Let's look at a few examples. Here you can see a composite wall with masonry block core, fiber sound insulation, and gypsum plasterboard skins. The wall is crossed by a smaller and larger MEP penetration. We need to calculate the quantities of the various materials in different ways. Even though there are holes in the wall, we need to buy the entire gypsum board and the insulation rolls or boards. Therefore, we need the gross area for both materials. For the core of the wall, however, we need the net quantities or special conditional values. How does this work in practice? Open the new Enhanced Calculation Rules dialog under Project Preferences and set up component level conditional rules beyond the element level rules. Use Building Material Classification to control what components the rules should be applied to. In this example, the concrete block, structural building material, which is the core of the composite, is classified as concrete masonry. For the concrete masonry material classification, we don't subtract holes that are smaller than 0.5 square meters. To comply with local standards, set up component level rules for the volume as well. User-defined and configurable conditions make it easy to list components based on their material contingent function. Let's look at the calculation results in the schedule. The gross areas are shown for all three materials. For the concrete core, we can also see the conditional value, since we have a larger and a smaller hole. For the net area, both holes have been subtracted, but in the case of the conditional value, only the bigger one was, because the other one is smaller than the size that was set up in the project calculation rules to be ignored. You can rely on error-free, auto-synced schedules and accurate calculations generated by Archicad. Architects and MEP engineers can seamlessly collaborate on projects of any size or complexity thanks to Archicad's built-in Mep Modeler Opening and Label tools. Create openings easily with the opening tool from any MEP elements created with the built-in Mep Modeler or received from the MEP engineer via IFC files. All it takes is a simple click for the individual ducts. Merge openings for smaller pipes if they are too close to each other. Optimize these openings further with the MEP systems and then share them with the structural engineer. It's easy to design openings in any shape using Archicad's Polygonal Opening creation method. Let's take a look at a few examples. Create polygonal openings in any 2D or 3D view with the improved opening tool. Here we can see a polygonal shaft on the floor plan. Activate the magic wand, then space-click inside the closed polygonal wall to create the opening in the slab with the desired shape. Convert existing rectangular and circular geometries into polygonal shapes by using flexible editing options. Let's cut a rectangular opening into this structural wall on the floor plan view. Then modify it for accuracy in 3D or in the section view and change the geometry for the specific needs. Follow this workflow when you receive IFC files with multiple provisions for voids from engineers. Select the provisions for voids. Use the context menu and choose Create Openings from Selection. Choose the Merge Nearby Openings option and set the desired parameters. After that, set the opening's accurate size and shape and make additional adjustments of the shape if necessary. Enjoy greater design freedom thanks to Archicad's enhanced opening tool and get more accurate models and quantity takeoffs. Use Archicad's dedicated Mep label when documenting the Mep system in your project to display MEP-specific data. Let's see how it works. Place this label on some MEP elements and learn how to customize the content it displays. In addition to general settings, such as text and pointer settings, you can define what data to display and how. For example, the value only, the name and the value, the prefix, and the value, and so on. Turn the display of information on or off, depending on what you need in the documentation. Add custom properties if needed. For example, the IFC type. Specify the units of measure. Instead of using the project preferences settings, you can override it and use millimeters. The labels can be placed on MEP elements not only on the 2D views, but on 3D documents as well. The MEP label is associative to the MEP elements, so if any element data changes, the information displayed in the label is updated automatically. Use the Improved Label tool to generate more informative and accurate drawing sets. Architects and designers rely on a wide variety of 3D objects based on the latest residential and commercial trends to create powerful designs for their clients. Thanks to Archicad's large and continuously expanding 3D object libraries, it's easy to create multiple interior design options for clients to choose from. Design stunning contemporary interiors in Archicad thanks to modular cabinets and highly customizable objects including sofas, ottomans, and a beanbag chair, dining and composite chairs, coat racks, clothes hangers, and a variety of outdoor grills. Each 3D object is highly parametric and contains a wide range of customizable components that are arranged in one easy-to-use graphical dialogue. After defining the sizes and other basic parameters, check your object by rotating it in the elevation or the 3D view of the live preview. This won't affect the object's position in the plan view at all. Bring your interiors to life thanks to our expanding library of 3D objects that follow the latest trends in residential and commercial design. Create stunning professional design presentations without workarounds thanks to Archicad's powerful out-of-the-box presentation tools. Apply the same high-resolution surface textures on 2D views that you already use in 3D. In this example, the surfaces are represented with the Surface Color Fill option. Let's see how we can make this view more appealing by using the enhanced settings under the Model Appearance section. Apply the Non-Shaded Surface Texture Fill option. In addition to the stone cladding, wooden, concrete, and other surfaces, the glazed curtain wall is also worth experimenting with. It applies a texture with an image of the cloudy sky. Apply soft shading and vectoral cover fills on top of the textures to create spectacular sections and elevations. Create a sense of depth by fading distant parts of the building. Draw attention to what's important in the foreground by checking the Fade Distant Elements checkbox. Select the Shaded Texture Fill option and turn on the shadows. For an even more restrained view of the background elements, display the distant elements with no textures and shadows, but with their contours only. Create vivid interior elevations with realistic details using the same presentation tools. Customize the direction of the sunlight to apply the most appropriate shadows. Use surface-based fills to heighten the look of your design documentation. Access and apply surface textures using fills. Choose the surface type fill and select one of the 3 surface-related display options: color, cover, or texture fill. Modify the alignment of the pattern as you would with any other fill. Use the surface type fills to experiment with and present multiple design options in various sections, elevations, and floor plans without changing the elements themselves. Create high-impact design documentation with Archicad's powerful out-of-the-box presentation tools. High-quality architectural documentation requires architects to run multiple types of quality checks on their projects. Use graphic overrides that are more flexible than ever, thanks to the new option to choose custom RGB colors. Let's see an example of how to use this feature to check the fire resistance rating of all types of elements across the project. Let's look at the floor plan and the 3D view. We want to visualize elements with various fire resistance rating values using the same colors on both views. In this example, there is a graphic override combination already set up for this purpose, called QA Fire Rating. The yellow represents all elements with a 60-minute fire resistance rating. Orange overrides represent a 90-minute fire resistance rating. We will now create and add a new rule for the elements with a fire resistance rating of 2 hours. Let's check the fill type, the fill background pen, and the surface override options. Use the new option here and choose the same RGB color instead of a pen and surface. Let's pick the same red color for both the fill background pen and the surface, so there is no need to create a pen and a surface attribute matching in color to synchronize visualization between 2D and 3D views. Check the fire rating categories relying on the colors on both views. Create a high-quality, accurate documentation while saving time thanks to Archicad's flexible graphic override functionality.